Good morning, everybody. So, are you ready? Let me start today's lecture, okay? So, please open today's content. So, today's content is 09 hyphen C hyphen slide 1 PDF. So first, please enter the WebCT system, Blackboard Learn system. And please open today's contents, this content. So today's topic is numerical calculations. Second topic of the C programming language. Okay. Actual content is shown here. First, I introduce variables, okay, and substitution, a very fundamental functionality, and we also introduce a library function, and I also introduced two standard functions: printf function and the scan function, okay, and I briefly also show how to use the debugger of Visual C++ IDE. Okay. Finally, I introduce exercise. So this should show the about variables. So variables in computer systems, variables are some boxes located on the computer memory. And such boxes have any data, any values. Okay? So as shown here, variables are treated as a container for data. So data, there are several types of data: numbers, string, and characters, some literals. Okay? And also you have to assign some name for variables. So variable names that treat as an identifier of the container for the variables. So these are some important features. Okay, if you when you assign variable names for variables, you have to keep these rules. Okay, so variable names consisting of alphabets, numbers, and underscore. And number cannot be used as initial letters of the variable name. Okay, and variable name are case sensitive. To distinguish capital or small letter. Okay. So in these cases, one variable is defined. The variable name is I. Okay, and so in the computer memories, I is treated as one box. Okay, so inside this box, you can store any values. In this case, 5 integer number. So each box has its unique name, and any data can be stored into the box. And so actually, each box has its own data type. So because the data type is different, the necessary size of the data are also different. So you have to specify, you have to define the data type: integer type, floating point number type, or double precision floating point number, string number, and so on. Okay. So this sheet also shows a standard guideline for specifying the variable name. And of course, it's better to assign the variable name easy to understand, especially such a name should be correspond to the meaning. Should be corresponding to the meaning of data actually stored in the variable. And too short name is not good. Also, too long name is also not good. Okay, so this is a good case. This triangle consists of two variables, base and height, usually. So in this case, base and height are treated as a variable name for calculating the area of the triangle. Okay. So there are some types of the numbers. Okay. So basic number is a bit. Maybe you know the bit. Bit is the base of information. The bit is treated as the information unit. Okay. So 0 or 1. And byte, 1 byte consists of 8 bits. Okay. And so in these cases, so binary number in the computer systems, all numbers treated as a binary numbers, 0 or 1. Okay. So if you want to treat an integer number, such number should have the 1 byte length. In the computer systems, 8 bits are prepared in the memory. Okay. So the first place, rightmost place, treated as 0, 1, and the leftmost bit place is treated as 2 to 7th power. Okay. And in these cases, this place is 1 and this place 1. So this means that 2 to second power of 2, and this case is only 1. So totally, this number means 5 integer as decimal number. Okay. So if you prepare 1 byte, 8 bits, you can treat the integer number 0 to 255. Okay. Can you understand? So in the computer system, you can treat more than 1 byte, 2 byte or 4 byte, sometimes 6 byte. Okay. So of course, 1 byte can treat 8 bits, 2 byte treat 16 bits, 4 bytes 32 bits. Okay. So each data can treat these integer numbers. Okay. So this is very important. In computer systems, it's difficult to treat the variable length bit. Okay. So in the computer, in your program, you have to specify any data, 1 byte data, 2 byte data, or 4 byte, 8 byte data. Fix the length size data. Okay. So in the computer system, there are several types of the CPU. 32-bit CPU or 64-bit CPU. Maybe your computer, inside your computer, CPU can treat 64 bits. So because So Microsoft provides a different type of OS, 64-bit operating system or 32-bit operating systems. Okay? So if you use a 64-bit operating systems, your CPU can treat maximum data size as 64-bit. Okay? And before using the variable, you have to define a variable named variables by specifying the variable name. Okay? So, I'm showing here several types of variables. So, for example, a character type, a short integer, long integer, unsigned integer, unsigned character, and so on. Floating point, a precision, a number, and double precision, a floating point number. Okay, so actual size, this data type has how many bits? Such a information is declared in the one of the header files, limit.headers. So if you check the content of these header files, you can find each data has how many bits. Okay. So this case is an integer variable case. So the previous example of the triangles, you have to specify the two variable base and height. So using this specification, this expression, you can define base variable and height variable and area variable as integer number. Okay, int base comma height comma area semicolon. Okay, this is an actual declaration in your program. Okay, so in these cases, in computer memories, there are three boxes prepared like this: base and for height and for areas. Each box has the same size, same bit. In these cases, if your computer is a 32-bit computer, maybe integer has a 32-bit size, so each box has a 32-bit size. So as shown here, you can treat the integer number from this integer to maximum these integers. Okay? So very big numbers. So once you declare variables, initially each variables corresponding boxes located in the computer memory have nothing, usually zero value stored. Using substitution operators, usually you have to store any data into variables. Okay, like this. In this case, variable A is substituted by 5. So the box for this variable A will have the 5 integers. This case, okay, and this case is a variable B, a box for variable E will come to have the A multiplied by 5. Okay. So using substitution operations, you can store any data into the corresponding variables. So the left side term should be a data or any literals. Okay, literal means concrete data. Okay. So concrete data means string or any unknown values. Okay. And also, so this cases, variable I is treated as a decimal integer, integer variable. So in this case is 5, decimal 5, integer 5 stored into this variable. And also this case is 0x to 0. This is a hexadecimal number. Okay? Hexadecimal number. So if you put the 0x in front of any numbers, in this case 2, 0. Okay, so this number is treated as a hexadecimal number, like this. Actual number, this number has a 13 other decimal numbers. Okay, so because 2 is this place to become 32, and in this case, it's the first place is 0. So it's a 0. The totally 32 decimal number. Okay. So in this case, is variable j has a 32 decimal number, and the third line. Variable k has a addition of I value and j values. Okay, so 5 plus 32. As a result, this k will have the 37 decimal number. Okay. So the important thing is equal character is not treated as equal in mathematics. In C program, equal character is treated as in substitution operators. Okay. And as I explained, literals, several types of literal, character literals, string literal, integer literal, float number literals. Okay. So the literal is treated as concrete data. Okay, like this. So actual program is shown here. In this case, is an integer variable I, j, k are defined, and float number variable defined. F0, F1. Okay? And I has a 5 decimal number, and J has a 32 decimal number. And K, as a result, K has a 37 as a result of this calculation. Okay? And after that, you can also calculate the division, J divided by I. In this case, F0 should have the floating point number. いくつだ? J 2 5 maybe 60.4. Okay? 6.4 floating number. So this is a difference. Sorry, I took a mistake. So in these cases, F0. And do you know the what number should be stored in F0? Do you know? So this case and this case are different. So because this division operator divides integer number of J and integer number of I. This calculation result usually should be integer numbers. Okay, because this variable treated as integer and this variable also treated as integer. So the return value also treated as integer. Even if you use a float casting, this return value may be 6. So this variable maybe have 6 decimal number. So contrary, this case is, so initially this variable is treated as an integer variable. This also treated as integer variables. However, using float casting, you can change the original data type into the other data types. Okay? So in these cases, return value should be treated as floating point numbers, single precision floating point number. This also treated as a floating point number. So the calculation result should be treated as a floating number. Okay? So as a result, F1 variable should have the 6.4 floating point number. Okay. So next I introduce a library function. Last lectures I also already introduced the meaning of the function, library functions. So library function already prepared by the systems. So any function you can use even if you don't define the content of such functions. Okay, so however, when you use any library functions, you have to include any include the corresponding header file. In these cases, if you want the mathematical functions, sine, cosine, tangent, logarithm, in this case you have to include a math.h header files. So because this header file contains the prototype definition for these functions. Okay, as I explained in last lectures, using these library functions, the compiler has to know the prototype definitions. Okay, so you have to include this header file in your program. Okay, so arguments are written in parentheses. Okay, and so as I already explained, it's better to use already defined function like library functions rather than you define. Okay. So this is some usage of the library function, cosine function. Okay. So this case is COS is a function name, and inside parentheses, in this case, there are one arguments. So such arguments are treated as a variable theta. Okay. So actually, the compiler have to know the actual value of these variables to calculate this function. So this argument should be literals. Okay. 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 And today I introduced two standard functions, two of the library functions. First one is the printf function. So last lecture I already introduced these functions. Using this function, you can print out any data on the computer screen. Okay. So so usually before using these functions, you have to include this header file, standard io.header file. And the printf function has this format. There are several arguments. Okay. So first arguments are already treated as a format string. So format string defines how you want to output the values of second argument, third argument on the computer screen. Okay. So actual example is as shown here. So first argument is a format string. In this case, this is a so this is a code string for each variable. So D means a decimal. So this variable I should be a decimal integer. So usually standard integer variables. No. So D means the decimal number. So variable I, also jk, should be defined as integer numbers. Okay. So decimal integer, okay. Hexadecimal, octodecimal, also okay. So D, in this case is inside one format string, there are 4 code string D. As I explained, D mean the decimal number. So value, actual value of this variable I output on the computer screen. Its place is here. Okay, and the number of places become a 5. Okay, so code string. For code string, you have to put the percent mark the front of this code. Okay, so as a result of this format string, just a minute. So later I will show the actual example. So second example is using floating point number variable. So in this case, f0 is treated as a floating point number. So if you want the printout output on the computer screen, the value of this variable, you have to use the f code string. F means floating point number. Okay. So this variable corresponds to this code. This variable corresponds to this code, and also this corresponds to this part. Okay. So f treated for the floating point numbers, you have to specify the location of the point. So in this case, the storing size is a 7, and so 7. And point 3 dot point. So you specified a point 3. Okay. So as shown here, 7 places located on the computer screen, and 3 decimal places. Okay. And decimal point, and the remaining are 3 places. Okay. So if you use this sentence, printf function, and ijk has 32 and 150 and 182 respectively. So actually the program will output on the computer screen like this. Okay, so for this code, this string will appear, and space and plus character and space and 5 length string, and space equal character space and 5 length string. Okay. So this is an important point. If you specify the length of the string for 5 characters, however, actual value of variable k is over 1, 2, 3, 4 over 1 billion 1 million. So in this case, it's leftmost place the number omitted. Okay. So actual code, character, and their meaning, and the corresponding data type as shown here. Okay, so this is very important for using format string. Okay, so maybe it's difficult to somehow difficult to remember. So if you don't know what kind of the code character you can use, so please refer to this page. Okay. So CSDUOKF, the meaning of the character and string and signed decimal integer. Okay. If you use only the character as code characters, so initially this treat for signed decimal integers. Okay. So as I explain later, you can use unsigned prefix for defining variables. For example, unsigned int, unsigned float. In these cases, the corresponding variable treated as unsigned numbers. So such cases, for such variables, you have to use u or o or x. So because these are treated as unsigned decimal, unsigned octal, unsigned hexadecimal. Okay? And so the corresponding variable is a floating point number. You have to use the F character. And also you can use E characters as a code for exponential representation. The corresponding data type, float type or double type. Okay. So the other data type, if you want to treat the integer numbers, you have to specify such a variable using int. However, using format string, you can output the actual value of such data, such variable, as a decimal integer or octal integer or hexadecimal integers. Okay, usually these number don't have the these values are not treated as signed, only treated as unsigned. Okay. So this is actual examples, several cases. Okay. So this case are decimal. So printed string shown here, and okay. So this case is actually a computer print out 6 characters. However, the actual number is 301. The only rightmost 3 places displayed. Okay. So as I explained, usually if you specify the 6, the length of the string for this data at 6, usually the computer outputs only 6 characters for this data. So if actual data has larger than these specific places, usually the leftmost places, values, numbers are omitted. So anyway, it's better to make a program of this, and please check the result. Okay. So this case is you don't specify the maximum size of string for this data. This case is specified. Okay. This should show the actual program, a simple program. So this program calculates the addition of 5 and 3, or substitution from 5 from 5 minus 3. Okay. So using 2 printf functions, such a result will be displayed on the computer screens. Actually, this program, this declaration is not necessary, unnecessary. So this case is use casting. Okay, as I explained already, this case is F0 should have integer numbers, even if this variable treated as float numbers, and because the return value of this calculation usually become integer numbers. This case is this case, the result of this calculation become float numbers. So because using casting, each variable are treated as floating point numbers. Okay. And so to actually make this program and execute the execution program, you can check the result. Maybe results become like this. So maybe this value become this, and this value become this. So next standard function is a scanf function. Using printf function, you can print out the actual data of variables on a computer screen. So sometimes you want to enter any values, literals, into the corresponding variables. In such cases, you have to use the scanf functions. Okay, so scanf function also has several arguments. Similar to the printf function, the first argument is treated as a format string. Okay, so second and third argument usually specified by variable or literals. Okay. So you can use scanf function like this. If you specify the variable c as character data using code character c, you can enter one character into the variable c. Okay. So in this case is the and mark. This is very important. And mark is used for specify the address, location of variable in the actual computer memories. Okay, so if you don't use and mark, computer treats this variable as the actual data located inside these variables. However, if you put the and mark before the variable name, this form treats it as an address for the corresponding variable, location of the computer memories. Okay? So using scanf function, computer can store the entered character into the correct position in the computer memories specified by and C. Can you understand? So as I explained, if you declare variable, character variable, as character name, variable name is C. Okay, in this case, C is the variable name for character variable. Actually, this variable has one box inside the computer memories. Okay. So to store, if you enter capital A using scanf functions, this literal, this case is a character A, should be stored inside this box. Okay. For treating this, the program have to know the location of these variables. Okay, so using and mark, the computer know the so usually the address is specified for the location of the memories. Okay, so in this cases, variable C has 4 variable C's. This box is prepared, and this location is 0, 1, 1. These cases, so you can, if you use and mark for C variables, actually this horn treats as the address of 0, 1, 1. Okay, so by specifying and variable name, you can let the program know the location of these variables, and the program can store the entered character by you correct location into the correct location. Okay. So as I explained, the and mark means the memory address of the corresponding variable. Whenever you can use a scanf, whenever you use a scanf functions, usually you have to put and mark for each variable. Okay. So these cases, C is a character variable, so you have to use the code character C. And this case I is treated as an integer variable, so in this case you have to D character for code character as code character, and F, in this case is F and DF treated as a float point number and double operation floating point numbers. So for these variables, you have to use F character or LF characters as code characters for these variables. Okay. Usually L means long. Okay, long floating point. So this should show also all the code and the meaning and the corresponding data types. Okay. So as I explained, it's difficult to remember all of them. So if you don't know the what code you can use for the scan function, so please refer to these pages. This page, okay? So C for character, S for string, D for decimal integer, and LD, long decimal integer. If you specify any variable as long int, okay? So this case is the corresponding variable has a double size of integer type. So in this case, for this variable, you have to use LD characters as code string. Okay, and O for octal integer, and X hexadecimal integer, and F and LF. I already explained. So Oh, so as shown here, this is a very important. As shown here, if you use scanf like this, actually this case is variable f is declared as a floating point number. So usually you have to specify f characters, f character for code string as code string for this variable. So however, in this cases, D is used. Actually, D is used for the decimal number. So somehow maybe the result, the actual data stored in this variable is strange values. Okay. So maybe as shown here, data is input a decimal integer, even if data type for the variable is different. So because in this case you specify the decimal numbers, so entered value is treated for decimal number. So third program is for using scanf function. Okay. So very easy to understand. So two variables, I and j, are defined as the integer data type, and using AND mark, you can specify the actual address of the computer memory for these variables. And using scanf functions and using this format string, you can enter two decimal integer by keyboard input and store into the corresponding address of computer memory. Actually, such an address is prepared for these two variables. And addition, substitution, okay. No. Addition and subtraction. And fourth program is also for scanf function. In this case, is x variable and the variable are treated as a floating point number. And so you have to specify the f character as code string for these variables. Okay. And this is an explanation of today's content. And so finally, I introduced briefly how to use debug. Just a moment. So as I explained last lectures, you have to create, first of all, you have to create a source program. And using the C program compilers, you have to exchange from source program into the execution program. Okay? And these are almost same. So there are two types of executions. By selecting build solution, this case is only the compiler output the execution code. So another execution operator is a start debugging. Okay, this case is the compiler once make an execution program and automatically execute the program. And if there are any errors, runtime errors, so there are two types of errors: runtime error or compiling error. Okay. So of course, there are any errors, especially syntax errors. The compiler easily find such errors. So however, no. So actually that is errors. However, not syntax errors. Such error is difficult to find out. So even compiler sometimes cannot find such errors. So however, such error will occur in the executing time. Okay, so the later case is runtime errors. So especially for runtime errors, this debugging is useful. You can check each sentences one by one. Okay. So anyway, actual usage of the debugger, please try. Okay. So in this content, there are some typical errors. So if you have enough time, please check these errors later. Okay. So this should show the first exercise of today. So please enter this program and please execute, and please check the result of the execution. Okay. So it's better to have the program output using these format strings. And the second exercise is a 3 program you have to make. Okay. So first one is calculate two values. Calculate the division of two values, A divided by B. Okay. And second program, print out the actual result of A divided by B using printf function. And the third program is somehow difficult. So this program should calculate the two integer number of variable x and y. Okay, these variables are treated as the number of two animals. So turtle and cranes. X, in this case, x is treated as the number of turtles, and y is treated as the number of cranes. Okay, and the turtle has 4 4 legs. No. 4 legs. And of course, 1 head. And crank has 2 legs and 1 head. Okay? So, variable A is treated for the total number of their head. And variable B is treated for the total number of their legs. Okay? So, the value of variable A and values of variable A and B are known. You can specify. Then the computer calculates the values of X and Y. Can you understand? So A equal X start for X plus 2 by X plus. Okay. So X is the total number of turtles. Y is the total number of clams. Okay? And clam has 2 legs, and turtle has 4 legs. So total number of legs of turtle and clam is A. And B is the total number of heads. Okay? So this program calculates the actual number of X and Y, not AB. For value of AB, you have to specify. Okay? So do you have any question? No? So please try to make these programs